All right, let's talk about something that might have given you nightmares in school, fractions. But what if I told you we could make it all make sense? And even make it delicious? Yeah, that's right. Today, we're ditching the boring textbook examples and we're going to use things like chocolate and parathas to break it all down. So, here's what's on the menu. We'll kick things off with a weird chocolate puzzle. Then we'll look at fractions that are basically the same thing in disguise. After that, we're settling a big paratha debate, talking about what happens when you eat more than one whole thing. And finally, I'll give you a little toolkit to make this all super easy. Sound good? Let's jump in. Okay, first stop on our food adventure, the chocolate contradiction. And the big question here is, how on earth can 1/3 of something be bigger than 1/2? I know, it sounds like it completely breaks the rules of math, but stick with me, it'll make sense. So picture this. There's this person, Tamana, and she's got 2 chocolate bars. She makes this wild claim that her piece, which is 1/3 of a bar, is actually bigger than your piece, which is 1/2 of the other bar. How is that even possible? I mean, we all learned that 1/2 is bigger than 1/3, right? And here's the trick. It's not about the fraction itself. It's about the whole chocolate bar. See, a fraction is just a piece of something. So if Tamana's chocolate bar is huge, then 1/3 of it could easily be way bigger than 1/2 of a tiny little fun-size bar. So the big lesson here? A fraction is pretty much meaningless unless you know the size of the thing it's coming from. Okay, so we've established that the whole is super important. Now let's zoom in on the pieces themselves. This next part is all about how fractions can be sneaky, how the exact same amount can go by a bunch of different names. Let's start with something easy. Here we have a rectangle. It's split into 3 equal parts, and one of them is shaded in. Pretty straightforward, right? That's 1/3. Okay, now watch closely. What happens if I just draw a line right through the middle? The shaded part is still the exact same size. I haven't changed that at all. But now, instead of 3 pieces, we've got 6, and 2 of them are shaded. So just like that, our 1/3 is now also 2/6. Let's do it again. One more line. Now look, we have 9 total parts, and 3 of them are shaded. So we went from 1/3 to 2/6 to 3/9. The name keeps changing, but the amount of shaded area, it's exactly the same. And that, my friends, is the whole secret behind equivalent fractions. So what are equivalent fractions? Well, they're just different ways to write the exact same amount. Think of it like nicknames for a number. 1/2, 2/4, 4/8, they all look different on paper, but they represent the exact same chunk of the whole. All right, let's spice things up a bit. It's time for the Great Paratha debate. We've got a couple of friends arguing about who ate more, and we're going to settle it. Let's warm up with an easy one. So, Sivi eats 1/3 of a chikki. Shami eats 2/3. The bottom number, the denominator, tells us the pieces were cut into the same size, thirds. So all we have to do is look at the top number, the numerator. Who has more pieces? Shami does. 2 is bigger than 1. Easy peasy. Shami ate more. But it's not always that simple. Let's get to the real debate. Our first friend says, I ate 4/6 of a paratha. And the second friend comes back with, oh yeah, I ate 4/5. Okay, so who's the winner here? They both ate 4 pieces, but the size of those pieces is different. One is 6ths, the other is 5ths. What do we do? Here's a rule that might feel a little backwards at first. When the top numbers are the same, you look at the bottom numbers, and the one with the smaller bottom number is actually the bigger fraction. Why? Well, think about it. If you cut a paratha into only 5 slices, those slices are going to be pretty big, right? But if you cut that same paratha into 6 slices, each slice has to be smaller. So 5ths are bigger than 6ths. So it all comes down to this. 4 big pieces are definitely more than 4 small pieces. That means 4/5 beats 4/6. The second friend wins. Debate settled. Okay, we've been snacking on parts of food this whole time. But sometimes you're just really, really hungry. So what happens when you eat more than one whole thing? Let's find out. So in our little story, Ma is super hungry. She grabs 5 pieces of paratha. But here's the catch. Each piece is only half a paratha. So how much did she actually eat? Well, she had 5 pieces, and each piece was a half. That's 5 halves. And this thing, 5/2, has a special name. It's called an improper fraction. It sounds kind of bad, but all improper means is that the top number is bigger than the bottom number. It's just a little signal that tells you, hey, we've got more than one whole thing here. So let's figure this out. How many parathas is 5 halves really? Well, you take 2 of those halves, and that makes 1 whole paratha. You take 2 more halves, that's a second whole paratha. And what's left over? Just 1 single half. So 5 halves is really just 2.5 parathas. And we call that a mixed number, because it's a mix of a whole number and a fraction. All right, we've gone on quite the journey. We've tackled contradictions and debates. Now let's wrap it all up and give you a super handy fraction toolkit. These are some really simple tricks you can use to compare pretty much any fraction you see. Okay, here are 2 of my favorite mental shortcuts. First, always ask yourself, is this fraction bigger or smaller than 1 whole? So if you're comparing, say, 7/8 and 8/6, well, 7/8 is obviously less than 1, but 8/6, that's more than 1. Boom, you're done. 8/6 is bigger, no contest. The second trick is to compare things to 1/2. Is a fraction more or less than half? 3/6 is exactly half. 5/8, well, that's just a little bit more than half. So right away, you know 5/8 is bigger. See? These little benchmarks can save you a ton of work. And there you have it, your foodie's guide to fractions. We learned that the size of the whole is everything, that fractions can be masters of disguise, and we picked up some killer tricks for comparing them. So I'll leave you with one final little puzzle to think about. If a tiny ant is 1/4 of a centimeter long, how long would a line of 16 of those ants be, all walking together? Give that one some thought. Thanks for joining me.